In this video, we are going to do convergent and divergent nozzle. So that we are going to take fluid flow and then click on the geometry and take the new design model. For that, we are going to take XY plane, select the plane. And now, before going to the geometry part, first we have to see the CD nozzle. We have to draw a symmetric diagram of CD nozzle in this demo with these dimensions 25, 35 and 50, 10 mm and 75 mm. With these dimensions we have to draw nozzle so that first of all we have to change the units to millimeters. Now select the sketch, go to sketching option, polyline and draw a rough diagram of the nozzle. And at the last point, click the right button and close links. Now go to constraints and select the symmetry. Now select the X plane over here and then connect the points. Sorry. We must be careful that the point is selected or not. So this is done. Now we have to go to dimensions. Dimensions, as I said, this should be 25 and this should be 35. This center part should be 10 mm. And this is 50 mm. And the length of this nozzle is 75 mm. Now the nozzle is done. Go to concept, surface from sketches, select the sketch, apply, and then generate. So the nozzle is generated now. Then now again go to sketching. Select a line over here. Draw the lines. Now go to modify option and trim the extra lines over here. So now go to dimensions and take horizontal. From the center point to this, both the lines what we have drawn, that should be 5 mm. Both the lines I'm taking as 5 mm and now generate it. So this is done. Now I am going to tools and select the facelift here. Now target face is the whole body. Apply. And the tool geometry is the lines which we have drawn now. Select the first line of this, apply, and then generate. And again, same, going to tools, facelift, and select the remaining nozzle. This is already done, this part. So the remaining nozzle and tool geometry, select the middle points. Apply, generate. And now again go to tools, facelift, and the last part. So apply and generate. So now you can see the individual parts of this. The nozzle is separated now, and this is done. We can close the design modeling. And now we are going to mesh part. So double click on the mesh. Now our mesh part is open, and select the XY plane over here. Right click on the mesh, generate mesh. So that the mesh will be generated first. Again right click, insert, go to method and select the geometry the whole nozzle. So apply. And now automatic method. Right click over there, insert and face meshing. Select all the parts and apply. And right click on face meshing, insert, and now select the sizing. In this sizing, we have to select this corner option so that I'm selecting this, the edge and the middle line and this total edge. These three and apply. Element size I am taking as number of divisions and I am giving number of divisions as 20. So now this part is done. Now we have to give the namings. So select this part and right click over here. I'm giving this as inlet. And next this part I am selecting, right click. This part is outlet. And now select the walls. All the edges we have to select. I'm giving this as walls. Enter. So now you can see the names. Inlet, this is the inlet which is highlighted in red. Outlet and the walls. Now this mesh part is done. Before closing this, once generate mesh and update it. So now you can close the file, close meshing, open setup part. Now in this double position, okay. So now our setup part is opened. First, in this general decision, we have to take the type of material as density based. The general part is done and we are going to modeling. We are turning on the energy equation. Click on OK and the modeling part is done. Now we are going to take the material. I am taking the fluid material as air. In that I am taking the density as ideal gas and the viscosity as Sufferland and then the temperature will be shown here. Once we have to observe this and click OK here. Now change the dimensions and close this. So now the material is done. Now I'm going to boundary condition. Inlet. I'm taking as pressure inlet over here. And reference line gas total pressure I am taking as 3 into 10 power 5. So click on OK. and outlet, pressure outlet we have to take. And in the outlet, the gas pressure should be 0. Once if it is 0, you can close this and open the valves now. In the valves, this no slip should be on. And now it is on. I'm closing this. And now the boundary conditions are done. Now then, directly going to insulation. In this, I'm going to take standard insulation, compute from inlet. The gas pressure is 0, velocity and temperature once we have to check it, and insulate here. Now run calculation. Number of iterations I am giving as 2000. Calculate. Now you can see the graph over here. At certain point, the graph will be increasing and then it will be reduced. Now the complete graph is calculation is done. Okay. Now we are going to graphics. In graphics, we have to select contours. In the contours, this filling part should be on. And now of these conditions, the pressure, first we are going to do for the pressure, save and display. I will show you. So in this way, the nozzle is generated in the pressure condition. And now I am changing this to velocity, save and display. This is the velocity condition of the nozzle. And now I am changing to Mach number condition. See how the nozzle is, how the color is varying in the nozzle. Now I am going to plots. I am taking XY plot. Here I am taking the walls as and plot the graph. So you can see the graph over here. See the graph how it is. And once it is done, close this. And files, close fluents. Okay. And now the last part, that is result. Same, select the XY plane over here. And we will be having streamline over here. Select it. Okay. Starting from, I'm taking as inlet. I'm giving the points as 100. Apply. So the points are generated over here. Now we can see the animation video. On the streamlines. You can see how fast the velocity streamlines are going. So this is done.